All right, let's go through this review for our quiz. It just says determine the convergence or divergence. So, and if I can, I'm going to find the sum. I guess I don't necessarily have to do that. For this first one, I know that this is going to diverge because it's a general harmonic. But, so my answer can be diverges, but it can't be because it's a general harmonic. I have to show the integral test. So f of x is equal to 1 over 2x minus 3. F of x is positive, decreasing, continuous for x greater than or equal to 2 for this one. And I can show the limit as b approaches infinity of the integral from 2 to b of 1 over 2x minus 3 dx. I need to show that this diverges. So there will be a little bit of u sub happening. So du divided by 2 is dx. That means we're going to get the limit as b approaches infinity. So there will be a 1/2 that I'm going to pull out of this, times the integral from 2 to b of 1 over u du. And that's equal to the limit as b approaches infinity of 1/2 times the natural log of absolute value 2x minus 3 from 2 to b. And that's equal to the limit as b approaches infinity of 1/2. Get my 1/2 on the outside here. ln 2b minus 3 minus ln 1. If I put the 2 in, 4 minus 3. This comes out to infinity because the natural log of infinity is infinity. And so therefore, I can say that this diverges, the series diverges by integral test. All right. My next one has a denominator that can factor. So that's my clue that this might be telescoping. Now, it's not going to be true telescoping because see how these are not just like +1 apart. So I am going to have to split this into partial fractions and then expand out some terms. So one of the fractions will have a 1 over n plus 3. One of the summations is 1 over n minus 3. I'm going to use the cover-up method to see what these come out to. So if n equals -3 for this first coefficient, I cover up n plus 3 and I plug in a 1 over -3 minus 3. So I get -1/6. And if n equals 3, I get +1/6 using the cover-up method. So I need to factor out a 1/6. And then put the positive term first. So this is 1 over n minus 3 minus 1 over n plus 3. If 1 over n minus 3 is b sub n, b sub n plus 1 would be 1 over n minus 2. These are quite far apart, so we're going to have a lot of surviving terms. How many surviving terms is dependent on how far apart these two are. So this might take a bit of math here. So let's see. So 1/6. All right, so we're starting with 4, remember. So when you plug in n equals 4, you're going to get 1 minus 1/7. So I'm going to need as many terms until I get to the 1/7. That's probably going to cancel. So when I plug in 5, I get 1/2 minus 1/8. Plug in 6, you get 1/3 minus 1/9. Plug in 7, and I get 1/4 minus 1/10. Plug in, you can kind of see where this is going. Plug in 8, and you get 1/5 minus 1. What was I putting in? Okay, minus 1/11. And then put in the next one is, where am I? 9. So I'm going to get 1/6 minus 1/12. Plug in 10, 1/7, there it is, minus 1/13, plus dot dot dot, plus 1 over n minus plus 3 minus 1 over n minus 3 plus dot dot dot. So yeah, the 1/7 will cancel with this one, and that means eventually all of the terms that are being subtracted after that will cancel, but the 1 will stay, the 1/2. There will never be another one of these numbers that are leading up to something under 1/7. The rest of these are going to cancel. Now, in interest of time, I am going to add these on my calculator, which I don't have open, so I'm just going to do this kind of off the screen here. So now for our quiz, I do not have you adding up all of these fractions. Not that it's impossible, but just for time, that's kind of silly. So 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. So I'm just doing this off screen. I'm adding all of this up and multiplying by 1/6. And I'm getting, okay, so I need to show this officially though. So this is going to be, the sum is going to be the limit as n approaches infinity of, what did I just say? 1/6 times 1 plus 1/2 plus 1/3 1/4 plus 1/5 plus 1/6 minus the last term, 1 over n minus 3. And that comes out to 49 over 120. All right. Ooh, okay, so 2 long ones to start. This next one looks pretty short though, so let's take a look at this. This is 1 over n times the 4th root of n. Let's rewrite that. You can add these exponents. N to the first and n to the 1/4 is 1 over n to the 5/4. And this is a p series. P is equal to 5/4, which is greater than 1. So this series, this previous one I didn't answer, converges. It's like telescoping, so I'm going to say telescoping. It's not pure telescoping, but that's kind of what we did. I guess what we really did was, well, no, that's it. That's what we did. I was going to say we did that limit definition, but we didn't do the original limit definition. All right, so p is bigger than 1, so this series converges. Converges by p series test. On the quiz, there will be 1 line for converges or diverges, 1 line for the test. You've got to show a bit of work for integral and telescoping, but not really much work for p-series or anything else. Number 4 is supposed to be 3 times 1 over n to the 0.95. So that's supposed to say 0.95. So if p is 0.95, that's a p-value less than or equal to 1. So this diverges by the p-series test. For number 5, this one's geometric. R is equal to 2/3. A sub 0 is equal to 1. So not only do I know what this converges, I know what it converges to. 1 over 1 minus 2/3 is 1 over 1/3, so that's 3. So this converges. If the direction said find the sum, I just found the sum. Converges to 3 by geometric series test. For this next one, this is also geometric, but R is a value bigger than 1. R is greater than 1. So this diverges by the geometric series test. Or you could say diverges by nth term test. I would take either one on that because it is geometric, so it is something to the n power. So diverges by that rule, but also the terms, when you have a base number that's bigger than 1, well, that's 1 or bigger, the terms are not decreasing towards 0. So that fails the nth term test as well. All right, for number 7, this is not geometric. It's not telescoping. and it's not a p-series, so we need to do integral test for this one. So f of x would equal x over square root of x squared plus 1. For x greater than or equal to 1, f of x is decreasing. Actually, wait, is f of x decreasing? I could do integral tests, but let's go back to this. We've done these limits. What about the limit as n approaches infinity of n over square root of n squared plus 1? We've talked about this before. The plus 1 is insignificant when you start plugging in large numbers. So this is essentially n over square root of n squared as we go on, and that's essentially just n over n. So these terms are approaching 1 rather than 0. So actually, I can save myself the integral test. This diverges by nth term test. I'm not going to take the time to do the integral test, but I imagine that you should get diverges by integral test as well. Except I would say it doesn't apply. Integral test doesn't apply because these terms are not technically decreasing to 0. So I think we have to stick with that. All right. Next one, I see 2 p-series, so you can show these separately. It's not telescoping because remember, you're not factoring this out. These are just 2 p-series being subtracted. So this series converges and this series converges. So both of them together converge by the p-series test. They both have powers that are larger than 1. Okay? Anytime I see something that's kind of compound interesty, I say, wait a minute, we know that limit. The limit as n approaches infinity of these terms. Are they approaching 0? No, they are not. This is equal to e to the a times b. So e to the 6th is not 0. So this series diverges by the nth term test. What about natural log of n? Again, nth term test. The limit as n approaches infinity of natural log of n, that's equal to infinity. These terms are growing. Remember, a natural log graph, it grows slowly, but it does grow. So this series also diverges by the nth term test. All right, let's take a look at this one. So for this one, this looks like we're going to have to do integral test, right? Because it's not a polynomial I can factor to get it into telescoping, and it's not any of the others. So let's do, and these terms are decreasing to 0. So f of x equals 1 over x times ln x cubed. F of x is positive, decreasing, and continuous for x greater than or equal to 2. Because remember, natural log of 1 is 0, so anything after 1 that you're plugging in will be positive. So we can take the integral, let's do limit as b approaches infinity of the integral from 2 to b of 1 over x times ln x cubed dx. We've seen this before in notes and in homework. We need to do u sub, where u would need to be ln x, because du dx will be 1 over x, which we have, 1 over x dx, or you can solve for dx. So when I plug in x du, that x will cancel with that one. And then we have u to the 3rd. All right, so I'm not going to rewrite this in interest of space. I'm just going to go ahead and integrate. So the limit as b approaches infinity. So I have 1 over u to the 3rd, or u to the negative 3rd. So that's going to be u to the negative 2 over negative 2, or negative 1 over 2 u squared. And that's the limit as b approaches infinity of negative 1 over 2 times ln b squared minus negative 1 over 2 times ln 2 squared. This is why we rewrite our negative exponents. When I plug infinity into this, I get negative 1 over infinity, so that's 0, plus this constant. All right, so this thing converges. If the integral converges, then the series converges by integral test. Right, so we have that. Let's see. Number 12, ln n over n to the third. So I think on this one, let's see, are we going to do like, I guess it's got to be integral test, right? This might be an integration by parts, but if I want to do that, because the terms are definitely approaching 0. If I want to do integral or the integration by parts, the tabular method, I've got to rewrite the table. I think we can do that. I'm going to do that work up here though. So let's see. F of x would equal ln x over x to the third. And those terms for x greater than or equal to 2 are positive, decreasing, continuous. So we would need to rewrite this though. Sorry, get all of this in here. So that it's like n to the negative 3 times ln, x to the negative third times ln x. Because remember, you only use integration by parts if you have a product. And if we're doing this, then our Liate says u has to be ln x, and this has to be x to the negative third. We only do one round of derivatives and integrate one round. So this is going to be x to the negative 2 over negative 2, like that. Put in your signs and your diagonals. So this comes out to, I'm going to bring this here. So the limit as b approaches infinity of, what do we have here? So we have negative 1 over, we have ln x negative over 2x squared. That's going to get evaluated from 2 to b. And then this last part, remember, is an integral. So this is minus negative, so plus. I'm going to pull the 1/2 out. The integral from 2 to b, oh, there's a limit in there, of 1 over x times, so 1 over x cubed dx. That can be integrated. That's 1 over negative 2x squared as well. All right, so what do we get with all these limits? So we get, I'm kind of skipping some limit notation steps. Let's just go ahead and plug stuff in. Remember, natural log grows more slowly than a quadratic. So this is small infinity over big infinity. So you are going to get 0 for that first term. And then minus negative ln 2 over 2 times 4. And then plus, there's a 1/2 out here. And then 1 over infinity is 0 again, minus negative 1 over 8. All of these are constants, so that tells me that this converges by integral test. You don't have to simplify. This is just what does the integral converge to. So yeah, I get a number for that. But as soon as I see that I have all these constants and no infinities, that's just like, okay, that's a number. So they both converge. State the conditions and conclusions of the integral test. If you've been doing this all along, then this should be no issue. F of x is positive, continuous, and decreasing on x greater than or equal to whatever it says. The integral and series both converge or both diverge. It's my informal way of saying that. State the conditions and conclusions of the nth term test. So if the limit as n approaches infinity of just the sequence is not equal to 0, then the series diverges. If the terms are approaching 0, investigate further. State the conditions and conclusion of the geometric series test. So first, know what it looks like. The biggest thing for this test or for this quiz is to just study what form does the series take to use this test. So it looks something like this. If the absolute value of r is less than 1, should say this, between 0 and 1. Can't write today. Then series converges, and we can say what it converges to a sub k, whatever that is, over 1 minus r. And if the absolute value of r is greater than or equal to 1, series diverges. Conditions and conclusions of the p-series test. So this one would look like n equals whatever to infinity of 1 over n to the p. So if p is greater than 1, converges. If p is less than or equal to 1, diverges. It should be between 0 and 1, but like if p is negative, then you fail the nth term test if this becomes n to the whatever. Conditions and conclusion of the telescoping series test. So if you have something that's perfectly telescoping, if you have bn minus bn plus 1, then that series is equal to then it converges, and it's equal to the limit as n approaches infinity of b1 minus bn plus 1. Converges to this value. If not true telescoping, but it's still the difference of two bottom-heavy rational expressions, then expand terms. And it converges. It's got to be subtraction. And you've got to be looking at both of those terms. They're just 1 over something linear minus 1 over something linear. A series converges if it's, fill in the blank. A series converges if it's, what am I going for here? If its sum converges? Let's see, a convergent series is saying if it's, interesting. I need to look up what I mean by this. A series converges if it's, I'm just going to say sum converges. I'm sure I've got something else for that. Let's take a peek at an old answer key here. Silly. I don't know what I'm getting at there. Oh, yeah. Right. We don't have to do that for our quiz. That's why I was like, what? If it's, this was our old definition, series of partial sums converges. This was the one that says you come up with something for S sub n, you see what that formula is, and that's the sum of the series. Write the harmonic series, including the first 5 terms. Does it converge? No, it diverges. The harmonic series is this, and it's 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus ... The harmonic series decreases to 0, just not fast enough. All right, that finishes this review. I think there's an AP classroom review, but honestly, our quiz is not any AP problem. So if you have been doing the homework and you know what the different types of series look like, you should be in very good shape for the quiz.